Welcome everyone to today's lecture on permutations and combinations, a fundamental concept.
We will understand permutation through a simple yet essential setup. Imagine three boys A, B and C standing in front. Both seats must be filled to count as one arrangement. If only one seat is filled, then it can't be valid one possible arrangement. Similarly, for an arrangement to be valid, no single boy may occupy both seats simultaneously. This is a permutation problem because the seating arrangement depends on who sits where. Swapping the positions of the boys would result in a completely new arrangement. If C sits in the president's seat and B in the vice president's seat, that counts as one valid arrangement. If they move and change their seats, then that would create a completely new valid arrangement. This shows that order is important, as both who sits and where they sit make a significant difference. Now, we will explore all the possible ways the three boys can be seated in the two different chairs, where the order matters. Since we need to seat exactly two boys in two chairs, each outcome must always involve both chairs being filled, ensuring that two chairs are connected in every arrangement. We place the three pairs of chairs along the x-axis as there are three possible boys to seat in the president's chair. Then, we show each respective boy sitting in the president's chair. This means that either A, B or C can sit in the president's seat, giving us three possible choices for the president's chair. Now it's time to fill the second seat, the vice president's. There are two other eyes available to sit in the vice president's seat. So we duplicate each of the seating arrangements, resulting in two possible configurations for each. For example, if A is seated in the president's seat, then either B or C can be seated in the vice president's seat, creating. Similarly, whenever B is seated in the president's chair, either A or C could sit in the vice president's seat, resulting in two possible seating arrangements for this scenario as well. Similarly, whenever C is seated in the president's chair, either A or B could sit in the vice president's seat, resulting in two possible seating arrangements for this scenario as. Thus, for each of the three choices of boys for the president's seat, there are two possible choices for the vice president's seat. Altogether, this gives us 6 possible seating arrangements. And this is equal to permutation formula 3p2,